In this video, I'm just gonna give a rationale behind the third section of the topic portfolio, which is analysis and explanation of key principles. So I'm just going to discuss why I laid it out the way I did, and I'm also going to discuss how I would teach this topic and the principles within it, which just is the last slide of this topic. So basically, how I started off this section was Damon outlined in one of the first lectures that if a pupil needs to construct a circle, needs to construct anything, the basic principles, where are they going to learn these in order to take it into this topic? So what I did was I looked at the technical graphics syllabus and what topics would pupils definitely need to have an understanding of in order to apply themselves in surface geometry. So what I identified was plane geometry and figures, orthographic projection, and circles. So obviously circles, there's different types of pipework, there's different transition pieces. So and obviously then into developments, pupils are going to have to show an understanding of circles. They're going to have to be able to construct circles, perhaps divide them. So that's one area where basic principle of circles would be developed is in the TG syllabus, that topic. Plane geometry, angles, triangles, different shapes. Pupils are going to have basic knowledge and skills of how to apply themselves here, and then obviously with orthographic projection, the different views. So you might have a transition piece or a piece of duct and you need to show it in plan and elevation, maybe a side view. So pupils are going to have to know the difference between the plan, the elevation, this end view, and yeah, just have a basic knowledge of these three areas definitely in order to apply themselves. So when I identified the TG subject, I then went into DCG. So which topics would pupils definitely need to know and have covered before beginning surface geometry? So the oblique plane. So finding the dihedral angle between surfaces or determining the dihedral angle between adjacent plane surfaces forming objects are key principles and skills that were developed in surface geometry. And obviously the dihedral angle is first introduced in the oblique plane topic, so therefore I feel pupils should have covered that before going into surface geometry. Then we have auxiliary projection. We know with, for example, here this is a piece of ducting where an auxiliary view is being obtained. There's lots of areas even in roof geometry we have to get auxiliary views to find a dihedral angle, so that topic would definitely need to be covered. Intersection of solids, obviously there's intersecting ductwork, intersecting pipework. There is lots of areas where solids are intersecting each other, surfaces are intersecting each other, so I felt that topic would also need to be covered before beginning surface geometry. And finally, developments and envelopments. Obviously this is probably the largest area, the main topic that would be linked with surface geometry, because obviously we're developing these surfaces out that we're being given. So then after identifying the topics both in TG and DCG, I started to identify the principles behind the key principles behind this topic. So as you can see, I first discussed the dihedral angle and I just created a video about it and the two methods used to find the dihedral angle. I then went into roof geometry. I did a construction of a question and just the main principles that a pupil needs to know in order to solve the questions surrounding roof geometry. And then the same with intersecting ductwork, pipework, transition pieces, and so on, joining pipes and ducts of equal diameter. So I identified all the principles needed through videos and just outlining it. So that was how I sort of identified what key principles need to be known through the use of videos. I felt that was the easiest way to do it, as it's better than lots of text just describing it through video format. So after doing that, after identifying the principles, I had to look at how would I actually teach this topic and the principles within it. So as you can see, I developed a mind map of just different stuff that I would imply if I was teaching it. So board work, the visualizer, activity sheets, PowerPoint, feedback, homework, resources, group work. So obviously I found very useful in teacher practice was board work, constructing something in front of the pupils, making sure your back isn't to the pupils, but up there in chalk, it's very visual and they can watch it as it happens. The same with the visualizer. It was very useful for pupils to you're discussing it and showing them at the same time. Activity sheets could be used, simple activities where maybe questions that might only take 5 or 10 minutes for them to solve, but it would be developing their knowledge. PowerPoint is obviously a good resource. I'll discuss that in the next section. And obviously, resources, homework to reinforce their knowledge and just to keep the workload on them, and feedback, obviously, giving the pupils constant formative feedback, and then summative feedback at the end in the form of a test. And group work, maybe we could develop, I thought of in resources was different types of roofs, and they could work in groups to find the dihedral angle of different roofs and whatnot. So it will be vital that the pupils have the topics mentioned previously covered before being introduced to this topic. The reason for this is that the pupils will have a good foundational knowledge of the principles within this topic, as I outlined already. So basically, these are just some of the methods I'd employ to teach this topic. Obviously, the teacher will need to have it as active as possible for the pupils. So that's basically just a rationale behind the way I laid out the third section of this topic portfolio. Thanks.